So once u is 0 and I have this, let's make t the subject. 60 by 2 divided by 10 will be equal to t squared. So we have t squared giving us root of 12 and root 12, 2 root 3. Okay, give me 2 root 3 in decimal. What's that in decimal?
3.46.
So 3.46 seconds. Yes, 2 dp is fine. So it means that this is the time taken by the body to move up there from the maximum height to the ground. So if I'm looking for the total time of flight, it is equal to this time 3.46 plus the time taken by the body to move from here to the maximum height, which is 2 in total, giving me 5.46 seconds. So that's the time of flight. Okay, are you okay?
Yes, please.
Another way out is this. You see, the time taken by the body to move from here to this part, and then from this part to this part can be determined. Okay, the time taken to move from this point to this point to this point. What's the time? What's the time there?
4 seconds.
Good, 4 seconds. Abba Bedu, are you okay? Bushra, Amma, and then Kuya, are you fine?
Yes, please.
So if you take 4 seconds to move from here to this part and then back to the same level, if I'm able to determine the time from here to this point, I just add that to 4 seconds. And it should give me the same answer as 5.46. I hope you agree with me. So let's determine the time taken by the body to move from this point to this point. Don't forget the height involved here is 40. So let me adjust the screen. We have using h, using over here we can even use v is equal to u plus 80, because once we are considering this and this, our v is the value we got when we took the square root of 1200. What did we okay, we got 34.64. So because we are considering this height of the tower, 34.64 is equal to, the velocity here is 20. So it's equal to 20 plus 10t. 10t is equal to 34.64 minus 20. And this is 14.64. When we divide this through by 10, we have this t to be equal to 1.464. Okay, what this means is that the body will take a time of 1.464 to move from here to the ground. Okay, now the total time from here to this point is 4. Therefore, the total or the time of flight So therefore, time of flight is equal to 4 seconds plus 1.464 seconds. And that will give us 5.464 seconds. Okay. And when we added the other one to good, that's what we got. Good. So the value is the same everywhere you go. We have the same answers everywhere we go. Please, are we fine? Are we okay? Hello?
Yes, please. Hi.
Are we fine with the solution?
Yes, please.
Okay. All right. So if you are copying, quickly, let me focus on the board properly. Okay. Please hurry through it and then let's continue. Can we continue?
Yes, please.
All right. I'm coming. I want to retrieve the next question. All right. Let's move to, I think, is it question 1? Question 1. And the question says that from the top of a 30-meter high cliff, from the top of a 30-meter high cliff, a stone is dropped. A stone is dropped from a 30-meter high cliff. At the same instant, another stone is projected vertically upwards from the ground with a speed of 30 meters per second. After how much and at what height from the ground would the two stones cross each other? Take gravity to be 10 meters per second squared. Okay, so a stone is dropped from the top of a cliff 30 meters high. At the same time or instant, another stone is projected vertically upwards. So it's like whilst one is dropping, okay, whilst a stone is being dropped, okay, then at the same instant, another one is being projected vertically upwards. And we have to calculate the time and then the height, okay, at which the two stones will cross each other. You see, honestly, questions like this, if you haven't solved its kind before, you may not be willing to even look at it. Because what kind of question is this? But if you go through it once, I mean, it's always solvable or simple. So it's better for us to, I mean, have a taste of some of this kind of questions so that we can apply it in solving subsequent similar questions. Please, class, are you okay?
Yes, please.
So let's first draw that we have a cliff. The cliff has a height of yes, what's the height of the cliff?
30 meters.
30
Okay.
meters.
So from the ground to where the person projected in the first stone, we have 30-meter height. So it can be severe on top of the cliff. You are projecting a stone downwards. Then at that same instant, I have a Piabuatima also projecting another stone upwards. At that same instant, a Piabuatima is doing this. We are to calculate the height or the time where the two stones cross each other, because they are all thrown downwards and upward at the same instant. Are we okay? So let's assume that the two stones cross each other at a height h. We are assuming that when the two stones cross each other at h. So let's h be the height, vertical height, where the two stones cross each other. That's the first consideration. The second consideration is that let t be the time where the stones cross each other. Okay. Now considering the first stone, I'm coming, let me change the marker. When you considering the first row, when we consider the first stone being projected from the top of the cliff to the ground, okay, this is free falling, but so using S is equal to UT plus half JT squared. What will be S? S, we are saying that let the two stones cross each other at their heights, vertical height H. Meaning that if we are looking for the distance covered by the stone, so the point where they cross each other, they will cross each other here. So if we're looking at this distance before they cross each other, how do we determine that distance, class? We are looking at this distance before the two stones cross each other. And this will be it, because we are assuming that H is the height, vertical height, okay, where the two stones would cross. So before they cross, it means that the distance, okay, this thrower or this stone would have to cover will be this. Please, do you see it? Do you agree with me?
Yes, please. Yes.
So what will be this distance? What will be this distance? Yes, a volunteer to help me. What will be this distance? This first stone, this is stone 1, would cover before crossing with. Yes, if the height of the cliff is 30, and we are assuming that they will cross each other at a height 8, then what will be this distance? Yes, Kelly.
Maybe half the height of the.
You see, Kelly, you can't say so because you have no idea. If you say half, then it means you know. And that is why we are only assuming that let this height where the two stones will cross each other be h. For h, we haven't been specific. Is that okay? It's just a letter. Okay. Yes, Anna. Anna, go ahead.
Study of this maybe 30 minus 8.
Exactly. Okay, it will be 30 because the whole height of the cliff is 30. So if we are assuming that the two stones will cross each other at this height h, then this distance traveled by the first stone would have to be 30 minus 8 before they cross each other. Is that okay? Right? So s is equal to 30 minus, let me adjust the screen. 30 minus h is equal to u is 0, free falling. So this will be half times 10 times t squared. Therefore, we'll have 30 minus 8 is equal to 5t squared as equation 1. Are we okay? Are we fine?
Yes.
Okay. Let me quickly go over. Because we don't know the vertical height where the two stones will cross each other, we are saying let that vertical height be h. So if that is h, when we consider the stone being thrown from up the cliff, it means that by the time it crosses, it will have to go through this distance. Okay, this distance. So distance covered by stone 1 before crossing. Okay, so this is what we are looking for. And when the height of the cliff is 30, 30 minus 8 would give us this. So when you consider the first equation of motion, you have 30 minus 8 is equal to half times gravity times c squared. U, this is free falling, so u is 0. Okay, now let's consider the second stone. Considering the second stone, please mute yourself if you haven't unmuted. I want a volunteer to help me. What equation do we draw for the second stone? The projection of the second stone. Yes, a volunteer to help me to derive an equation for the projection of the second stone. Yes.
Yeah. Please, can you shift the board? I want to write something, but yes, please, it's okay. Thank you.
Yes. A volunteer to help me write an equation for the second stone. We have considered the first stone being projected from the top of the cliff. What equation do we write for the second stone being projected from the ground? Yes. Juvial.
Please, can we use
Juvial, I'm waiting. Can we use
v square is equal to u square minus 2gs?
You are suggesting we use v squared is equal to u squared minus 2js. Okay, so what becomes v and u? You see, if you use this, the difficulty will be for v. You wouldn't know the velocity there. Fine, you have u, you have g, we have h. H is also a variable. Akosia,
Mr. I wanted to say
go ahead.
S is equal to UT minus half GT
So
squared.
Akosia is also suggesting that we use s is equal to ut minus half jt squared. Akosia, what will be h? What will be s?
The S
Yes.
is going to be 30 minus 5t squared.
30 minus 5. Akosia, open your eyes. You are overlooking something.
The second
Yes. What will be it? What will be the distance to be covered before crossing with the first one?
uh,
To the,
to come.
it's a question to the whole class. What distance will it? What distance will it cover before it crosses with the first stone?
Mr. Avia,
Yes.
is it H?
It is, yes, it's H. It is being thrown from the ground. So he are saying that let's okay, the vertical height where it will cross will this be H. So this is already H. Then this will have to be 30 minus this height. So that is H. Class, are we okay?
Yes, please.
So H would be equal to, the question gave us U. What is the value of U? What's the value of U given, okay, from the question?
30 meter per
No, so 30. T, we don't know. Minus half times 10 times t squared. So we have 30 t minus 5 t squared. So we have this to be equation 2. Okay, so equation 2 is this, and equation 1 is 30 minus h is equal to 5 t squared. So we solve equation 2 and equation 1 simultaneously to find t. Then we can find h. Start with. So 3 minutes to find t. Okay, because both equation 2 and 1 are all in terms of h and t. So we can solve them simultaneously. Let's quickly do it, then we move on. 3 minutes to find t. Are we through with the value of t? Hello? Hello, class. Akosia ya ba Zuviel ama epia